A friend of mine asked about Adafruit I2C library. Where to find it, what to do when you do find it, what functions there were, and the parameters in those functions. So this is going to be my attempt to try to explain it short and sweet. And yes, this is Halloween related, but this also got started because the purchase of the microcontroller was made before the knowledge was obtained of how to use the thing. So here we go. I'll try to explain it all. So here's the code, and right off you can see I'm on a Linux machine, but this can be used on Windows. You just get rid of the first line, and you see the imported modules: time module, OS module, and the Adafruit I2C module. Now, the first line after this, you got the I2C, a variable I2C equals Adafruit I2C, and then the hex value of the address that your device resides at on the I2C bus. Alright, once you plug that in, that will be assigned to the variable I2C. Okay, then we get down to the main loop of the program, and this is where the function in question comes in, the part that my friend had some difficulty understanding, and I'm going to try to make it understandable. So anyway, first variable bytes and equals this Adafruit I2C dot read list. That's the function, and here are the parameters, 3 parameters in that function. Alright, first thing you want to know is where do you find these functions. Since it wasn't able to find a whole lot of code for the Adafruit I2C, but it did have a URL, and it's a GitHub URL for here we go, Adafruit Beaglebone IO Python Adafruit I2C. Alright, and this is the source showing the Adafruit I2C class and all the functions in that class. And you got reverse byte order, error message, write 8, write 16, but the one we're interested in is read list. Alright, this is the function we're going to use to obtain the data we need to get the readings, or the bytes we need to make plug into our Celsius formula to get temperature reading. And read list has 3 functions: self, reg or register, and length. Self really doesn't help any because it's in a class, so the first parameter is always self. But if you dig into it a little bit more, you'll come down here and you'll see results. This variable results equals self.bus.read I2C block data, and this function here happens to be a function of the SM bus library, and I recognize it, so okay, so I'm on the right track. And the 3 parameters are right here: self.address, which helps because now I know it's an address, and that address is going to be the address of the device on your I2C. Okay, reg would be register, and this is where we have to look a little closer, and we're going to have to go to the data sheet, and it will be a data sheet for a TMP 102 temperature sensor. That's what he got, and we want to find out what the number of that temperature register is, and in the data sheet under application information it shows our registers: pointer register, temperature register, configuration register, T-low, T-high, and the only one we're really interested in is the temperature register. That's the one we want to get our data from. And right down here they have a helpful little table, and it lists all the registers, and it will give you the number. The temperature register is, well, 0, and the configuration will be 1, T-low register would be 2, binary 2, and T-high register would be the binary 3 register, but we're only interested in the temperature register, which is 0. So that explains where the 0 comes from. It's the register we want to get the data, our data from. And if we go down, well, too far, we look here in the data sheet, and it explains temperature register a little bit more. And where is it? We'll scan down here. Alright, it says this register stores the output of the most recent conversion. Alright, and it says 2 bytes must be read to obtain that data. And it's described in table 3 and table 4. Here's table 3, which is byte 1, and table 4, which is byte 2. So that tells me all the data I need are in the first 2 bytes that will be returned from that function. So if we go back to GitHub, Adafruit, we're looking at the function again. Alright, so we know the first parameters: address, the address that our device resides at, the register, which would be register 0, which we got from our data sheet, told us the register that we're interested in, that we want to get our information from, which is register 0, and the length, which is 2 bytes, the first 2 bytes of the list that will be returned by this function. Alright, so okay, let's go back, alright, to our program. So okay, we found out the function we want to use, which is Adafruit I2C. That's the module. Dot, the function is read list, and it needs our address. It needs to know the register we're interested in and how many bytes we want to read. Alright, now we return to bytes. Once we get that, we're going to split them up. Okay, we want the most significant byte, which will be in bytes 0, and least significant byte will be in bytes 1. And we'll plug that into our Celsius formula here, and then we will print it out and plug the Celsius into our Fahrenheit formula, and we'll print that out. We'll go to sleep for a second, and then we'll have the screen clear and do it all over again. Alright, we'll just get out of this and run the program. Here it goes. Alright, Celsius, Fahrenheit. And just to prove that it is working, I'll put my finger over the sensor. See the temperature go up. Take it away. Sensor temperature drops. Alright, we'll stop that. Get back to the program. Well, like I said before, this was for a Halloween project, and it is for a fog machine chiller. Basically, you want to automate dropping the broken chunks of dry ice into the chiller. Make it hands-free. Whenever the temperature drops to a certain amount, another chunk will drop in, and so on and so forth for the whole night, ideally. But that's it, short and sweet, and I hope this has been helpful, and we will see you later.